All right, good afternoon, everyone. Thank you for joining us despite the beautiful sunny weather outside. I promise you it's going to be worth it with Osama in the room. You'll get all the sunshine to his talk and the joys. But it's a pleasure to host Usama Fayyad from Northeastern University, who is the inaugural director for their Institute for Experiential AI. How many of us recall the field data mining? It used to be, before it became the big data, data science, now be AI. So as a computer scientist, there's this conference called KDB, which how many of us know about that conference, KDB? Right? And that's a place that you all like fight to get published, right? It's like tenure making or graduating conferences. This man here is the originator of that. In fact, back in 1995, and is the originator of the data mining field in many ways. Back in 1995, he and another friend of ours, Gregory Piatsky-Shapiro, wrote a game-changing paper on knowledge discovery and data mining, what it means, what it could be, had the courage to launch the workshop at that time that became a conference, then with ACM, and now has grown to be the flagship conference for all things data science, applied ML, etc. So it truly is, a lot of us are in this field because of Osama's leadership and foresight for creating this field. And Osama has got his PhD from University of Michigan, Ann Arbor. He never came to campus. He was dating someone from Notre Dame in his first year of PhD. And because he never came to campus, you know what happened to that. I said he was dating someone in his first year. He was a chairman he's been a serial entrepreneur founder and has also worked with various big organizations. He was a chairman of Open Insights that he founded in 2008 after leaving Yahoo. And at Yahoo, he was the chief a data officer, and his startup was also acquired by Yahoo Research Labs. He has served as the CTO of Oda Health, as a global chief data officer at Barclays Bank before actually coming back to academia at Northeastern. He's a fellow of ACM, fellow of AAAI. So has published many papers. So if you think about in the last 30 years, as I said to you, 95, while creating a new field, he was also changing how organizations function, behave, deal with data, and establishing their data strategies. And now he's sort of leading that foray into AI and what it means and how do we sort of transform enterprise level AI and engaging with research all across campus at Northeastern, beyond Northeastern. We are thinking about how Lucy and his institute can partner and figure out things together. So again, Osama, thank you so much, my friend, for joining us today.
Thank you. Thank you, Nitesh, for a very hyped up introduction. So I'll talk today about AI in general, and Nitesh asked me to kind of make it a more general talk. My initial plan was to do like a shorter, more technical, but so if you're very, very familiar with AI, maybe some of the stuff is not interesting, but maybe some of the stuff on kind of the secrets of making it work would be interesting. So let's talk about. See, after all the preparation. Oh yes. All right. So I would say kind of unlocking your phone with your face was the first very kind of widespread utilization of AI. AI today is everywhere. This is one of the startups we work with at the Institute. They can guess kind of brain disorder detection just by having somebody wear a virtual headset and kind of test for progression of things like Alzheimer's, Parkinson's, and so forth. Another startup went kind of the low-tech path, which is in order to measure progression of something like Parkinson's, what if you could just use a webcam? And instead of going to a clinic and very expensive, do the test frequently and get feedback quickly. This XR in general, augmented reality, virtual reality is being used in many, many interesting places, especially in manufacturing nowadays, where you can kind of look through and see what's inside. You could use it to kind of deliver coffee on a drone. But on the more serious note, on the right is a video that comes from a Swiss company where it's being used for delivering lab samples across a couple of places in Switzerland. But I show you this because there's one part of the video that's interesting. By the way, this, as soon as it takes off, it's AI that does the navigation and all of that, taking it to its destination. But just as it gets to the destination, I want you to pay attention to this window where it's going to dock. And if you notice underneath the window, there's this big QR code that's there to cheat. So AI stops and the classical navigation and control takes over, because as of today, we don't know, we cannot use AI to kind of navigate very precisely, right? So they had to do this kind of cheating trick. Nevertheless, this is for real, it's being used and so forth. Let's keep going. There's applications to kind of, you can't yet help the blind see, but you can aid them detect what environment are they in. Are they near a street? Are they near a crosswalk? Are there pedestrians? Is there a car? And so forth. AI itself, in case you're not familiar, has a deceptively simple definition. The one I like is the use of computers to simulate human intelligence. Big problem with this definition. To this day, we still don't know how to define intelligence, let alone common sense reasoning and things like this. And it's still debatable whether the Turing test has passed or not. My view is it hasn't been passed. Not that it's the ultimate test. What about machine learning? Well, it's a subset of AI concerned with, I would say, the way I would characterize it is we give up on the problem of trying to design algorithms for intelligence, and we use data to say, under these conditions, what should be the desired outcome? And that's kind of machine learning simplified. Effectively, it's fancy regression applied to a lot of decision making. We've had hype cycles before. The first one, and they were always followed by an AI winter. AI winter means people are denying they had anything to do with AI. There is no funding, and people expose it for the fraud that it is. So mid-1970, it happened the first time. The second AI winter, I was actually graduating from Michigan in the early 90s with my PhD in machine learning, right into AI winter number 2, where a lot of people were denying they had to do anything with AI, and I insisted on using it in my title. The hype continues to this day. And by the way, this hype stuff, if we have time, I'll show you an article from the New York Times in 1958 that hypes up the perceptrons. But anyway, nowadays it's Mr. Tesla over here, Elon Musk, who I wish would stop speaking. Since 2017 to today, every year he's been predicting that within 1 year we'll have full autonomous driving. His latest one is within 1 year of almost a year ago now. It's coming up like in early 2025. We will have an AI that's smarter than the smartest human. I completely believe this is not possible, not with today's technology, but it doesn't stop him anyway. You hear a lot of hype in the last AI winter. The US was afraid of Japan. There was this thing called 5th generation systems. Now we're very scared of China 2030. Probably this time more justifiably so. I actually think China's approach to AI deserves to be worried about, and in some areas they may be well ahead of us. But anyway, the hype still goes on. We're going to be jobless, brainless, useless, all of that good stuff. And we'll talk about that. Now, throughout these winters, machine learning did very well. And it's not because we came up with brilliant algorithms. We did not. In fact, I argue all our algorithms are super simple. But what happened is we have a lot more data. Between digitization and the internet especially, we had way more data than we ever did before, and that data drove a heck of a lot of these advances that we'll talk about. So AI, a subset of AI is machine learning. Subset of machine learning is generative models that we will talk about a lot. But if you look at it from the applied perspective, and if you imagine the size of the circle to be kind of the amount of applications out there, supervised learning, which is where every training example has a label, has a desired outcome, is definitely the majority of applications. Unsupervised, where you don't have the labels, you have some good applications, things like segmentation and so forth, discovering kind of new groups in the data. Gen AI is still very, very small when it comes to applications. We think about $1 trillion has been invested in Gen AI. The estimates for the return on that investment vary widely from 100 million to 100 billion. Huge range. But nobody knows. So far, it has not been a very kind of high return on investment, although I will tell you why we should realize that it's going to be with us for a while and it will have a huge impact. Then you've got, a lot of algorithms that you don't really hear about in the applied world because it's a very, very tiny footprint of applications. So I said I'll share with you the secrets that I actually kind of learned over the years. The first one is you have to narrow the scope of the problem as much as possible. In fact, you want to make it so narrow that you can have complete knowledge of the domain, right? So what do I mean by that? Like, playing chess. You know the whole world of chess if you know the board configuration and the rules. Fortunately, this applies in many contexts. Controlled environments like manufacturing plants with robots in them, or more commonly, say in financial services and other places, people do a lot of data manipulation and data entry by hand. Very robotic, very repetitive work, by the way, and a lot of it. So these things are possible. Now, the one thing I want you to notice about the secret is it's the anti-GPT philosophy. ChatGPT says, I gotta know 80 languages in every field of science, right? Here, I'm saying quite the opposite. You wanna know like as little as possible, but about this very, very narrow domain where you can actually know everything in that narrow. So reducing this, I'll use the example of machine vision, where machine vision was one of the grand challenge problems in the 80s and 90s. And if you look at problems like, well, here's a basket with a bunch of items in it. Can you tell me what's in it? As human beings, we do fairly reasonably well, even though you'll hear a lot of machine vision excuses like, oh, you've got orientation problems, partial occlusion, all sorts of things like that. But we solved this problem very, very effectively, right? And how did we solve this problem? Well, we put a barcode on everything, and we can scan it super fast under very bad conditions, dusty or dark or whatever, and very accurately. But it has nothing to do with how humans see. It has nothing to do with how we interpret images, right? Gives you no insight to that. And there was a joke when I was graduating with my PhD at the time was the machine vision folks keep saying, oh, we solved the machine vision problem. We just slap a barcode on everything in the world and we're done. But anyway, so you may have heard about, related to this, Amazon Go stores. I don't know if you had a chance to go into one. Lots of articles about this is the future of shopping and retail will change forever. Of course, as an engineer, when I enter the store, I don't really look at the stuff being sold. I look at the ceiling and I see a huge array of sensors sitting there to determine whether, hey, did Usama pick up the right chocolate bar and did he take it or did he return it in the wrong place and so forth. And I've often wondered, does this make sense? Does this investment make sense given the kinds of stuff I'm selling in the store? And my answer was always no. Sure enough, Amazon last April decided to discontinue the whole thing. There was a long explanation as to why customers didn't like it, which is not true. I think the real answer is it just didn't have the ROI. So that's secret number 2, which is a big deal. You need to have ROI. And by the way, I've been in many, many, many projects, tens of them, where maybe the technology team is super excited, or the marketing team is very excited, or you name it, the manufacturing team, and they promise all sorts of ROIs. And then when we do work on it, or we go in and we say that the CFO doesn't even recognize this ROI because it just doesn't make financial sense. Legal sometimes will block the whole work from going out. Execs sometimes are misaligned and so forth. So this is very important. It's not very academic, but it's very real. And you have to worry about all these aspects before you do these projects. And we'll come back to this. So some of the big challenges in AI is AI of today is almost all machine learning, and machine learning is highly dependent on data. Data is very expensive to get, and it's even more expensive to label, right? And this is really one of the biggest drivers of generative AI, where we don't insist that all the data is labeled. We kind of are okay guessing what the label should be and then believing our own guesses and having that machine work. But collecting this data and managing it has historically been a really, really hard problem. And people don't know how to do it. Companies still to this day don't know how to do it. Every AI project I get involved with very quickly becomes a data project. And it's a data challenge to try to get the right transformations and the right data collected. We'll talk a lot about data. The other side of data too is most of our data systems have been designed for structured data. And almost all data in any organization is unstructured. So if you're not working at a Google or one of these places that kind of understand AI, you're going to have problems dealing with that unstructured data because your data systems are not ready to kind of manipulate it and use it. So secret number 3 is collect data at very high granularity, outcomes and context. Context is hard. So why did something happen and what was going on around it when it happened? We'll talk about how the big AI companies do this and how much they invest in it. In most places, this is not captured correctly. A lot of the big guys are beginning to understand the importance of it. This is Jamie Dimon of JP Morgan Chase. His letter to shareholders in 2023 mentioned data 27 times and talked about 300 use cases of AI. In 2024, he kind of likened AI to the steam engine revolution and talked about 400 use cases in the bank. So at least they're beginning to get it, and they understand that data is a big deal. So what do you need to do to do this? And this is a huge opportunity still, is you need to have an AI data strategy. How do you capture data at the right level of abstraction, where you isolate yourself from all these messy operational systems, which will always be messy? How do you capture it? How do you manage the data rights and the access? And how do you create the safe guidelines for using it so that you're not doing bad stuff? In the equation of AI, you have depreciating assets like hardware and algorithms. These are going to be commoditized very quickly. And then you have the real investment grade asset, which is data. So that's really the most valuable asset right now in the equation. Now, we know that data is essential. The other part of this is kind of another hidden secret, which is interactions, human interventions. So not only must I capture events, outcomes, and context, but guidance back from humans, corrections to what you predicted, and the context for those. Why? Right? And why is the correction applicable here and not there? The AI haves, the big companies that do AI understand this extremely well. So if you talk about Google or OpenAI or whatever, let's talk about Google for a second. Google search engine. At the core of Google search engine, the thing that actually ranks the pages that match your query, your 2.5 keywords on average, is called MLR, stands for Machine Learned Relevance. It basically measures 500 to 700 features on every page on the web and feeds them through this mysterious box that decides how relevant they are to the query. That engine is retrained 4 times a day. There's about 1 million queries a day out of the billions that get selected by Google for review by an army of what they call search editorial, 25,000 people whose job is to look at queries and say, oh, this result should be moved down, this one should move up, this one is a meme, it means something completely different, you totally missed the answer for this one, blah, blah, blah. Stuff that only humans with their common sense reasoning, so these are generalists looking at query results. There's a whole science as to which queries do you select and how you review them. And the reason they do this 4 times a day is because it takes about a quarter of a day to review 25,000 queries. Sorry, 250,000 queries. That is then fed into the MLR for training again. And this is done 4 times a day, every day, and has been happening for 20 years. This is how Google got to where Google is today in terms of, and by the way, they've experimented with turning this off for a week or 2. And if you turn it off for 2 weeks, search quality goes down, almost exponentially. So you still need that human intervention, even in something like Google. And this is data from generalists, not specialists. Now, imagine all the data coming out of doctors and nurses and surgeons, engineers on manufacturing lines, right? People operating, credit risk in banks and so forth. Experiential AI is our keyword for AI with a human in the loop. We believe not only is human intervention a must, but it's a great opportunity to capture a lot of IP that today is kind of escaping into the exhaust. Nobody captures this in most companies that have these highly paid people, highly trained people working. You don't capture what they do, which is a tragedy. So secret number 4 is you have to capture every human interaction. And in most organizations, this is not captured. So this is another big deal as to why people are not kind of able to close the machine learning loop. So let's talk about generative AI for a few minutes, and then let's talk about what's been happening with generative AI for the last 9 months or so in terms of advances. So I take it everybody here knows generative AI is generating text, image, or any other forms from textual or multimodal prompt. Multimodal means I give you text and I show you an image and I say something that looks like this or sounds like that, etc. These models are called, the term I like from a very famous paper called stochastic parrots. They are parrots because no matter how eloquent they sound, they do not understand what they are saying. They are generating the answer, not even a word at a time, a token at a time. An English word is about between 2 and 3 tokens, right? So they operate in a completely different mode than how humans think, much like think barcodes and vision. But they produce stuff that is amazingly compelling. So if you feed it text, you get text out. If you feed it images, you get images out. If you feed it code, and we'll talk about programming in a second, you get code out. If you feed it voice and music, you get that out, and so on and so forth. For videos, there are some very useful objects which are hard for humans to manipulate, like DNA, protein folding, chemistry, molecular design, and so forth. And the outputs are very, very useful in those spaces. ChatGPT is just a chatbot sitting on top of the LLM. By the way, a couple of things that I want to dispel myths about this. You may hear a lot of people bragging, oh, our model is trained on all data on the internet. So let's talk about GPT-3. GPT-3 is circa 2020. That was the last time OpenAI was open. They became very secretive afterwards. So we know a lot about GPT-3. We know it's 175 billion parameters. We also know they tried for years to train it on a lot of data from the internet. And guess what? That did not work. Why? Because the internet is filled with data that is contradictory, sometimes false. Many times you have hate speech and other things. They had to basically spend a lot of money, curating about 1 terabyte of data. That's the training set that is balanced. And by the way, they went to things like Wikipedia, and later to things like, according to the lawsuit, New York Times. They compiled a lot of scientific papers because they figured people are not going to lie in papers. I think that's true most of the time. To do the training and to stay away from the stuff that's troublesome. And it's just a deep neural net. It's a neural net with about 175 billion weights in it. The capabilities were not really new, but they became famous. I'll tell you why in a second. But here's a question for you. So you have 1 terabyte of data, which fits on your laptop, and you want to train this neural net with 175 billion parameters. You hit the train button. We're going to ignore the cost of the hardware and the engineers and all of that. How much electricity do you think you burn to do 1 training session? And by the way, 1 training session never works. You need multiple of these because none of them goes well. To train GPT-3 on 1 terabyte of data. Any guesses? 10 million is one guess. Other guesses? This is just electricity, nothing else. It's about $3 million. Every time you hit that button, right? So this is where also a lot of capital is needed. The bigger cost that they don't talk about is how much it costs them to curate the right training data. And what is worse is we don't know. I mean, we know they have curated data for GPT 3.5 and for 4.0 and the alleged 5.0. We just don't know what it is. And we don't know. We know a lot about the 1 terabyte. We don't know a lot about the rest. And by the way, ask OpenAI to release that 1 terabyte, and they will not give it to you because they spent a lot of money collecting it, which tells you how important the data is. Anyway, it became very famous because it went from 100 million to from 0 to 100 million users in 2 months. It took about 70 months for a Google Translate or an Uber for comparison. There's a lot of estimates out there as to what it's worth. You know, McKinsey says generative AI is going to add something like $25 trillion to the global economy, a third of it in the US. I like this other estimate that I came up with by myself with a little bit of data. I actually think for knowledge workers in the knowledge economy, we will see acceleration between 15% and 80% of a task. And we'll walk through a couple of tasks. Significant acceleration. Total automation is not still there. You need a lot of human review and intervention. But what is the size of the knowledge economy? Turns out in countries like the US, the richer countries, over half the economy is knowledge economy. So even if the acceleration were to be just 2%, forget about my 15 or 80%, 2% means on the half of the economy means 1% of the US economy. That number is too large to be ignored. This is why these generative AI models will be with us for a long time, probably for the next 20 years. Even though scientifically, if we have time, we can talk about where it's interesting and where it's not. They're not that interesting as models. But economically, because we created this knowledge economy that's filled with robotic, repetitive, droning work, they can do a lot. So human in the loop is still essential. You need to check the output. You need to modify it, edit it. I always get asked this question, will AI replace my job? And my answer is always absolutely not. It's a human using AI who will replace your job if you're not using AI yourself because of that acceleration. And by the way, this holds for individuals, this holds for companies, for organizations, for universities, what have you. There's applications all over the place. I'm going to walk you through a couple of case studies. Let me skip this. If we have time, I'm happy to explain to you how these models work in 10 slides or less, but we probably won't have time. But even after you do all this pre-training, all this hit the button, burn $3 million, or my estimate for GPT-4, it's about $15 million of electricity every time you train. But we don't know because they don't tell us. But we can estimate. You still have to do a lot of the fine-tuning. And here is where humans are still very much needed. Again, OpenAI doesn't talk about this, but they do have an army of people who actually take the output of that LLM and start challenging it. They've been trying to standardize a lot of this. They tried to use automated methods like GANs, generative adversarial networks, didn't work. They needed humans to basically challenge the models. So let's now talk about kind of what's been happening recently. And maybe I'll tell you a couple of amusing case studies. We went from fascination to pragmatics. What is this thing worth? How much does it really deliver in value? Can you quantify the benefits? So let's talk about Microsoft's Copilot for Code. This is a study I've been struggling to kind of get published, conducted by one of these firms that has a lot of programmers who asked the question. By the way, when ChatGPT first came out, I was one of the few who thought this will eliminate programming, right? If it can do English so well, surely programming, learning how to do Python is a lot easier than speaking English. Turns out I'm wrong. Programming is harder than English because there's many ways I could say the same, meaning, and you guys can interpret it and understand what I'm trying to say. That doesn't quite map to programming. So how much will it increase the productivity of a programmer? I thought going into it, this is like a 80%, easy. So it turns out that the results are not that straightforward. So if you're a programmer that has very strong skills in programming, this will speed you up by anywhere from 60 to 80%. So let's call it 70% for this study. So your market value just went up by 70% if you use AI, right? Because you could crank out the code that much faster. If you don't have the skills, the results were very surprising. You're better off not using it because it actually takes you longer to figure out where the bug is, how to fix it, than to build the code yourself, right? Now, this has real interesting implications for Institute of Higher Education, by the way, because it says there's going to be this gap that's going to get even bigger and bigger between those who have skills and those who don't have skills. In fact, I believe the importance of skills will only increase the more we leverage AI, because you need to be able to judge kind of what's happening. Let's do a simple and fun case study in marketing. This is Gen AI with a J, and it came out from Virgin Cruises. And you'll see why it's called Gen AI in a second. So, all right. So this was rolled out. And the idea is, Nitesh buys a ticket to go cruising, and Virgin Cruises will say, well, would you like to send an invite to all your friends and family to join you? And the invite will come from Jennifer Lopez speaking the words you say and making whatever motions you come up with. It worked very well. They sold about 1,000 tickets in record time. Not surprising. why am I showing you this? Because it is generative AI. They use generative video and generative voice to match your voice to her voice. They had to use some tricks. So the AI may not know how to say Usama or Nitesh right, in which case they make J-Lo say, hey sailor, instead of hey Nitesh. They stopped the program because a lot of people started wanting to hack it and make J-Lo say a lot of inappropriate stuff and make a lot of inappropriate gestures. So it wasn't worth kind of that filtering. But the point is, it's kind of a new way of thinking of marketing. And what's scary about it is, we can all watch kind of fiction and be amused and say, well, it's easy to recognize. I can ask Dali to draw me an astronaut riding a horse in space, like it did here, and that's amusing. But what about in reality, right? What about, this is the famous one, a bit old now, who basically could make President Obama say whatever he was saying. More recently, a team of German scientists were able to kind of make Putin say whatever and act however they wanted to act. This is a photo of the now new president, I guess, being arrested in the streets of New York by the cops. But of course, it's a fake. It's not real. And of course, you can generate videos. The point, why am I showing you all this, is that the bar for generating these things has just gotten so much lower. We can generate these things in a matter of minutes to hours versus months to do it right. And it sounds more real than ever. You can get a message that's from your boss or your partner, and it sounds so real, right? And it's asking for information. All sorts of bad stuff has been happening. And the use of this stuff can be super scary. In fact, I was telling the group I met with earlier that I'm not too worried about AI becoming, like Jeff Hinton says, super smart and making us kind of extinct. I'm much worried about the use of AI as a tool to generate all sorts of misinformation where they will completely disorient the digital world that we live in. Right? What happens to you when you kind of no longer can believe anything you see on your mobile or a computer, and you can't tell? Because, by the way, I could generate a story about Nitesh. I can have the AI generate, 100 different variations of it. They all sound real. With each variation, I can have a whole website built.
Who's the best one?
Yes. And I'll have thousands of robo followers to that site. So if you try to do any kind of investigative checking, is this real? Did he really do this? The answer will be yes, right? And it's all fabricated. So that's to me the real scary part, which is kind of complete disorientation of our digital world, which leads us to responsible AI, right? And we talked about this all day yesterday here at a very nice conference. So to me, responsible AI is one of the key secrets here, which is, can you do these risk assessments for unintended biases, for built-in issues, detect those risks, and be able to address them all the way from kind of ideation to initial development to actual development to use and operations, and to when damage happens and you have to do algorithmic audits. Let's go through some of these quickly because we're going to run out of time. We're seeing technology now to try to overcome these problems. RAG is becoming very much kind of in fashion these days. Retrieval augmented generation is just a hack where you leave the LLM like it is, and you try to do two things. You try to standardize the inputs. So problems with LLMs are, if I change the prompt just a little bit, the answer may come out very, very different. So one hack is I can standardize any prompt into like a standard prompt. So they do an embedding, and they feed it the embedded vectors, and then they intercept the output. They do lookups, and they expand the prompt by adding more and more documents and so forth to refine the search effectively, automatically. And we're seeing it go all the way from kind of modular to what's called GraphRag is the most recent and more sophisticated, where you're using like more and more knowledge to do this. The problem with it is you're still trying to correct for the problems with the LLM. Larger LLMs are not necessarily better in my view. Smaller is actually much more interesting. We have a whole program called Better Together at Northeastern where we're trying to do these knowledge-informed, can I use a knowledge graph and a language graph, which is what the large language model uses, to create a smaller language model that is more robust. Why should I spend so much energy trying to memorize a table or a citation graph if I already have it and I'm pretty sure it's correct, right? The question is how to use it during the training and how to use it during inference. This recently became kind of, for many years, for the first 2 years, companies kept just pushing this hype of larger models are better. And we're going to come up with the next trillion parameter model, the next 10 trillion model, and so forth. Now they're beginning to recognize, hey, smaller could be faster, better, more efficient, etc. So let's look at a very quick case study in finance. I love this case study because Bloomberg allowed the team to publish every little detail of what they went through in doing this. They built a 50 billion parameter model. We'll come back to why 50 billion in a second, to address tasks like this. I want to generate a headline automatically. So here's a news article. The headline is home prices see biggest drop in 15 years, right? You could do one where you feed it other documents and it produces these headlines. Now, what they leveraged was many decades of articles where they had the article and they had the headline, right? So it was a very good training data set. But here's where the story gets more interesting. They got to be really, really good at this, by the way. So generating the headlines automatically, they beat every benchmark you can think of. But then they said, well, what if we use the same model to generate what's called BQL, Bloomberg Query Language? So write the query in English and let the machine generate the actual query. It did really superior, very, very well, very high accuracy performance in doing this because they had many examples of this. They developed essentially a domain-specific language to map kind of the functioning of this thing. They used it for sentiment analysis, same model. Sentiment analysis means, is this article positive or negative about this security? Auto entity recognition, who, what, when, where, why, how much? Answering financial questions about articles, summarizing articles, and we saw the headline generation. So amazing results. So here's a couple of interesting questions. Why was it 50 billion parameter language model? Well, turns out that the management team basically told the engineering team, you have $3 million worth of compute. Don't spend it in one place, use it wisely, right? And they basically went and looked up all the charts from Google and others that says, if you have a model of this size, here's how many floating point operations you need to train it. And worked out backwards and said, okay, 50 billion is the biggest model we can afford, right? So what happened? Why am I sharing this story with you? Because soon thereafter comes this model called X-Finance from an unknown company called Stochastic AI. They use the Llama 13 billion model. I don't like much of what Facebook does, but I am a fan of the Llama models and the fact that they're giving it as a gift, free not only for research use, but for commercial use. So these guys use the 13 billion model. They fine-tuned it on data that's very similar to Bloomberg's, and they were able to match or beat what Bloomberg did. Total computation budget, $1,000, right? Instead of the 3 million. 25% of the size, about 1,000 times cheaper, and of course more robust, because if I don't like the model, I can refine it quickly. Much harder to do when your model is bigger. In fact, this is the biggest reason why almost all the big LLMs can't keep up with news and other newer articles and so forth. So that's a reminder again of secret number 2, like what's the ROI and what should I be doing? I think basically the real question that Bloomberg should have asked is not what is the largest model I can afford, but it should be, in my opinion, what is the smallest model I can get away with? And that's a complete different philosophy on how to build these things, much more pragmatic. Few more developments we'll cover, and then we'll just wrap up. There's now easier ways to do stuff. GPT-4o, despite the fact that it's another stochastic parrot, is amazing. The Copilot integrations, I think we'll see a lot more of those, and we are seeing it being embedded in many tasks. If you ask me what's a great example of doing this, I'm a fan of what my friend Shantanu at Adobe did with Firefly. Basically, they built their own model, their own private LLM, trained on images that they completely own. So there's no copyright issues. They have their own image library over the last 40 years. They therefore were able to indemnify users against any IP rights issues, which is a big open problem right now. They integrated it in a platform, Photoshop, which is used by millions of users, in a natural, intuitive way, right? So in a few seconds, you can bring up an image like this and say, you know, maybe fill the background or something, or click on it and say, hey, put a classic car here, give me a reflecting pond next to it, and while you're at it, put a cloud there that looks like the car, right? And literally, this is a 10-second operation, right? So to me, this is a beautiful example of using the technology in a very useful setting where it addresses real problems. So secret 6 is incremental and continuous progress. Kind of don't go for the full blast applications, start small and do little steps, and soon you'll have magic on your hands. More major developments, LM agents. This is a very, very promising area where basically, instead of having one large model, you basically have an agent model that can spawn smaller models, right? So this is case study in cybersecurity. 0-day vulnerability means there's a vulnerability in your software, nobody knows about it. 0-day is when you discover it. Sometimes it's 2 years after the fact that it's been sitting there. And they were basically measuring how fast can we discover this or exploit it. They used a model that basically spawns a whole bunch of 7 billion llama models, and we're able to basically, for the harder task, harder than the 0-day, they were able to do it five times more efficiently than kind of a single LLM. If you tried something like GPT-4, they could only find 3 of the 15 vulnerabilities. They were able to find 8 out of the 15, which is significant. I don't have time to review the Devon thing, so I will skip it, but there's a video online and you'll have the slides. If you play it, it's pretty amazing. It's an attempt to model how a software engineer works. So it's kind of thinks about the problem at a high level, starts implementing it, etc. The trick they did was to say, oh, let's go to Upwork and pick up jobs, programming jobs, and see if Devon can start making money by basically moonlighting as a programmer for hire. And oh, this is gonna. I'm gonna. By the way, the video is very impressive, but I'm gonna skip it for now. The point I was gonna make about it was buyer beware. I spent a lot of time studying Devon, and then I also found out a lot of articles where they're disputing all the claims. So the video looks too good to believe. And maybe it is, maybe it's not. So we don't know. But the thing can generate a lot of code and can recover from a lot of errors and so forth. The video is worth watching. So the issues here, I don't like the word hallucination, because if you say the model hallucinated, you're attributing too much intelligence to it. These things don't have, they're not thinking, they don't have purpose, they don't have intent. They're just trying their best to kind of complete a prompt that you give them, and that's all they know. There's a lot of issues, and we came up with our own framework for kind of how do you address things like, market, law, and society constraints like reputational cost, regulatory issues, and systems kind of designed against us versus to help us. We have a whole, this came from a Verizon case study where we kind of applied our roadmap to different aspects of it. And they kind of loved the results so much that they asked us to hire an ethicist and dedicate that ethicist to Verizon. So they're an employee of the Institute, but they work only for Verizon. A few words about the Institute. We have about 100 faculty members on the tenure side of the house, and we have about 55 research staff and a support staff along with them. We divided into 5 focus areas, really 3, which are oriented towards applications. I think Sam Scarpino visited here and may have given a talk. He runs AI plus life sciences, where we think we can achieve a lot of kind of leadership in certain sub areas of that. AI plus health and human performance is Gene Tunick, which is mostly digital health, digital pathology, things like that. And AI for climate and sustainability run by Arup Ganguly, which is kind of really leveraging the age of big data and all sorts of complicated ways to predict climate and the consequences of climate events. We have 2 horizontal areas. Responsible AI is one of them. And the second one is what I shared with you a little bit, the better together, the hybrid generative AI, data and prior knowledge together. Some of these areas required us to address problems like, why have the AI advances been mostly in companies and not in academia in the last 15 years? And that's because the companies have data and problems. So we created the AI Solutions Hub to work with a lot of companies to work on their problems, co-work solutions. We created a responsible AI practice in order to basically discover what is responsible AI, what does it really mean, and what should the learning curriculum be. I'm going to skip this stuff because we're running out of time. I talked about this, I think. And in conclusion, the biggest issue, of course, is talent and training talent. I don't think if you took all the good institutes of higher education and combined and asked, can they produce enough talent to meet the demand? The answer is no. So there's going to be a big component around upskilling and training kind of existing employees, because that's the only way you're going to address this. And creating these programs required us to, over time, we developed a whole bunch of programs from AI literacy to business usage, technical usage, in-house expertise, engineers, executives and leaders and boards. We believe experiential education is key. So you can subject somebody to a lecture and they can attend for a few hours and be fascinated and then go back home and kind of go back to doing work the way they do it. Or you could do the learning in the context of a project where they see how they do the job today, how they could be doing it in a new way, and then it becomes way more relevant. Why is everyone saying larger models are better? Any guesses?
Larger number sounds better.
Larger number sounds better, but it's actually more evil than that, yes.
Well, I was going to say, I think the parroting sounds more natural in a lot of cases, so it's harder to detect a fake. Something synthetic.
If you're trying to address the general problem, that's true. If you're trying to do very narrow models, that's not quite true. So, turns out, you got to ask the question, who are these companies? Right? They're companies called Amazon, Microsoft, OpenAI. What's their business? Oracle. Their business is cloud computing. They want you to use more cloud services. The more, the better. So if it can take you 100 times more compute than you really need, that's good. All right. Last few thoughts. No data, no working AI. Human intervention is absolutely a must. And getting the data is not easy, but it needs to be done. It is a way to accelerate work, but not fully automating it. Keep that in mind. It can have a huge impact in the knowledge economy. And we'll see regulation coming in, EU already, China will be before the US probably. These are the 7 secrets that I kind of shared with you. You'll have the slides, so you'll have them. And of course, I welcome any comments or remarks on them. And with that, I want to leave some time for Q&A. So thank you for listening.